HS 5.1 Functions and secretions of the pancreas. Now, if you recall back to HS 1, functions and secretions of the mouth and esophagus, you'll remember the salivary glands, and the reason I'm bringing that up is because the salivary glands, in structure and function, they're very similar to the pancreas. In that they're an exocrine gland, they have acini with ducts, and essentially they're just very similar. So let's have a look at the pancreas, the functions of the pancreas. Well, the main function of the pancreas is digestion. Digestion of fat by secreting pancreatic lipases, digestion of protein by secreting proenzymes that become proteases, pancreatic proteases, to digest the protein. It also provides a good environment, and this is through the use of the duct cells. So it secretes fluid and bicarbonate to neutralize the gastric acid coming in from the stomach to the duodenum. And finally, the pancreas, of course, it's also got it regulates glucose with insulin from beta cells and glucagon from alpha cells in the islets of Langerhans, which I'm also going to be talking about. First of all, let's have a quick look at the sort of the layout of the acini of the pancreas. It's very similar to the salivary glands. You've got these acini, acinar cells forming an acinus with a centroacinar cell over here. The basal region is on this side, and this side is the apical lumen. And then you've got these ducts, which form a ductular network, which I'm going to talk about in a second, lined with duct cells. So in terms of the structure of the exocrine pancreas, well, like I said, it's a ductular network. It's got these intercalated ducts from the acini, and then it's got interlobular ducts between these, coming from within these lobules, which is a collection of lots of acini. And then it's got interlobular ducts, which is the duct between the lobules, finally leading to the main pancreatic duct, which then goes along the pancreas, along from the tail of the pancreas to the head, joins the common bile duct to form the ampulla of Vata. It's like the swelling where two ducts join, surrounded by the sphincter of Oddi, and released into the second part of the duodenum. So like I said, it's got this ductular network. It's got these acini here, acinus, with the various acinar cells, and the acinus, the various acini make up the lobule. Intercalated ducts coming from the acini, with a interlobular duct coming from the intralobular duct, coming from within the lobules, and then the interlobular duct, which is between the lobules, finally leading to the main duct, so from the neck of the pancreas all the way to the head and into the duodenum. So like I said, that main pancreatic duct, it comes from here, from the neck to the head. And what happens here is it splits off into the dorsal pancreatic duct, which is behind, and the ventral pancreatic duct, which comes forward. And this ventral pancreatic duct, it joins with the common bile duct. Like if you remember, the liver has the hepatic ducts, common hepatic duct. The gallbladder has the cystic duct. And these then join to form the common bile duct, which comes down, joins with the ventral pancreatic duct, which is the one that's coming forward, and it forms this swelling here. Now, this swelling is called the ampulla of Vata. And the swelling has a muscle surrounding it. The muscle is the muscular sphincter of Oddi. Remember, a sphincter is a circular muscle, and that always has a constant tone to it to prevent the reflux. Now, the opening that it forms is called the major papilla. Papilla is like a hole. It's called the major papilla because it's got the ampulla of Vata. It's like the main one from the common bile duct. But also, the main pancreatic duct obviously splits. The dorsal pancreatic duct, that enters into the minor papilla, which is here, of the duodenum. This is the second part of the duodenum. And one thing to note is that this major papilla, the point at which this enters the duodenum is where the foregut over here becomes the midgut. And the foregut is supplied by the celiac artery, by the celiac trunk, and the midgut is supplied by the superior mesenteric artery. Just a quick reminder of the arteries for you here. With the abdominal aorta descending down, The first branch of it there is the celiac trunk, then it's the superior mesenteric, and finally the inferior mesenteric. So the celiac trunk supplies the foregut, which is proximal to the major papilla, and the superior mesenteric artery supplies the midgut, distal to the major papilla, which is the opening of the ventral pancreatic duct and the common bile duct into the second part of the duodenum. So having a look at some of the cells involved. Well, like I said, you've got the pancreatic acinar cells, which line the acinus. And it's polarized, meaning it's different depending on which side. This is the luminal side, the apical lumen, with zymogen granules, which I'm going to be talking about in a second. Remember that, zymogen? Now, the O-gen, that implies that it's a proenzyme, such as, like trypsinogen, pepsinogen, which are from chief cells that we talked about. So these are just zymogen granules. It's got mitochondria, and it's got a rough endoplasmic reticulum. So that's the pancreatic acinar cell. Moving on to the pancreatic duct cell, which lines the ducts. Remember, there's intercalated, intralobular, interlobular, leading to the main duct. So this is the pancreatic duct cell, simple cell with mitochondria. And I'm not going to be really talking about the islets of Langerhans in a lot of detail, but this is it's sort of to do with regulation of glucose. It's got alpha cells, which are darker here, as you can see. It's the islets of Langerhans, this whole region here. This is the Acinar cells that I mentioned, the Acinar, and beta cells. So these pancreatic acinar cells that we've talked about, let's look at some of their functions. Well, role of the acinar cells. The acinar cells essentially do two things. They're for digestion by secreting pancreatic lipases, which are for digesting fat, and secrete pancreatic zymogens. Zymogens are pancreatic protein enzyme precursors, which I'm going to talk about in a second. So that's the digestion function of the acinar cells. And the next function is hydration. They secrete a sodium chloride isotonic fluid. It's a bit less important, but the main function of the acinar cells essentially is release these enzymes and this proenzyme. And in order to secrete these zymogens, these proenzymes, they have a few adaptations. So as we've seen here in the cell themselves. So let's have a look. Well, they have a rough endoplasmic reticulum. They have secretory granules, as we saw here, of zymogen, and they have a lot of mitochondria. So these three things essentially, they allow it to be adapted for protein secretion.